All right, let's take a look at the review for growth and finance. So I have a list of problems on the left, and then I have the 6 different formulas that you will be given on the exam at the top. And what I want to do is just discuss from the questions which formula we would need, and then also of the variables and constants in the formula, what values would we use? And then finally, what would we solve for? This video is not going to show how to solve for them. This is just more of a which formula and what do we know. So let's start off with this first question, number 1. And I'm going to highlight the things that I think are important. Suppose you want to have $300,000 for retirement in 35 years. Your account earns 9% interest. How much would you need to, here we go, deposit each month? Okay, so there's only one choice for deposit each month. It is the periodic compounding formula that allows for a monthly or a periodic deposit. Now, D could be for deposit or withdrawal. That's not enough information. But it's not a lump sum. We're not just putting the money in once and letting it grow. We're doing it every month. This is the lump sum. So this is the one that grows. So it's a positive exponent. It grows over time every time we make a deposit. So this is our first example, so you can see how this is going to be done. The A value is the amount that we want at the end. That's 300,000. The rate, we need to divide by 100 to get 0.09. The N, for these two formulas, the N value isn't how often it's compounded. It's how often the deposit or withdrawal or payment is made. So in this case, since it's monthly, we would have N equals 12. 35 years is how long we need to invest, so T equals 35. And the only thing left in this formula would be the D. So we would be asked to solve for D, or we would expect to do that. Okay, in this case, how much would you need to deposit? They're exactly requesting the D. Excellent. Next question. The number of houses in a town has been growing according to the recursive rule. P sub T equals P sub T minus 1 plus 146. And P sub 0 equals 985. So this is a growth model. There's no money involved. There's no interest rate involved. And knowing the recursive rule, we take the old value and add a number to get to the new value. Every time we add the same number, this is a linear growth or a constant rate of growth. This is for the linear growth model. So in this model, D is the 146. And of course, P sub 0 is given, 985. Now there are three formulas in here that have a P sub 0. So just saying P sub 0 in your problem isn't enough to know which one is right. This is an addition problem, and we see the plus in there. Exponential growth is multiplication. You won't see an addition from the old term to the next term. And here we also have some multiplication. This is the complicated one. This is the logistic model. So what we're trying to solve for, so we actually don't know whether we're trying to find a certain number of houses in a certain amount of time, or how long will it take to have a certain number of houses. So the P sub N and the N are left over. We need one more piece of information to know what we were expected to solve for. Number 3, you want to be able to withdraw 35,000 each year. So here we go, withdraw each year. So this is again a periodic deposit or withdrawal. So we would be working with withdrawing. Now withdrawal will make the value in the account go down. Decreasing account value. Oh, sorry, I just moved the video like crazy. Probably make people car sick. The negative exponent. So this is the periodic deposit or withdrawal with a negative exponent. So we want to withdraw $35,000 each year. So D would be the withdraw value. 15 years, that's T. Accounted in 6%, so R is 0.06. And how much do you need in your account at the beginning? Now also N is 1 because it's annual withdrawal. And then find the A value. Some formulas that might be P sub 0 or A sub 0, but that value is how much is in the account, so A also makes sense. Oh, I put all that in the wrong spot. That all goes right there. Apologize for that. Number 4. The number of street lights in a town is growing linearly. All right, linear growth, again, we have this form. 4 months ago, T sub 0, there were 44 lights, so that would be P sub 0 equals 44. Now at T equals 4, that's actually N equals 4 in our formula. And there are 72 lights, that's P sub N equals 72. So of the 4 variables in this equation, we have find D. So we could find D. This one doesn't actually have a question to it. So this is like the first part of the question. Then they'd get to the question later on. But already I can see that we could find D if we needed to. All right, number 5. You want to buy a car. The company is offering a certain interest rate for 4 years. What will your monthly payments be? Monthly payments. We're back to the monthly, the one with the D in it. How often? Monthly, 12. So let's see. We want to think about whether we have a positive exponent. This is going to be something that grows over time, or the negative exponent. This is going to be something that goes down or shrinks or decays over time. We're going to buy a $17,000 car, and each time we pay a monthly payment, I hope that we owe less each month. That value is going to go down every time we do a payment. So the one that goes down is the negative exponent. So we want to buy a $17,000 car. That's the amount that will be in the account that we owe money on at the beginning. What will your monthly payments be? We're trying to find D. And then we have 5% interest rate. Time would be 4 years. And N would be 12 because it's monthly payments. Okay. Trying to move all this without moving anything else. Oh, that's too bad. It doesn't all fit because now we don't see the formulas. Next one. Suppose inflation decreases the value of money by 4% each year. How much will 100 buy you in 25 years? Inflation decreases by 4% per year. Okay, so this is an increase or a decrease. So this is the growth problem. It's either the linear growth or the exponential growth. Linear growth is constant growth. It always grows the same amount each time frame, whereas exponential growth changes. It's a percentage growth. That's what we have here. We have 4%. So we have R equals negative 0.04 because the inflation is decreasing. Our initial value, P sub 0, is 100, and N would be 25. And then we're looking for P sub N, the only thing left over. Solve for P sub N. Next question. Suppose you have a $225 gift card for gas. You spend on average $23 per week for gas. Okay, so this gift card balance is going to decrease every time, but it's going to decrease the same amount every time. So this is a growth problem with a negative growth, and it's a linear growth because it's always going to be dropping by $23. So we would have P sub 0 is the initial 225, and D is negative 23, and we would need another variable to solve for something, but that's the information we do have. All right, let's read the next one, and then we'll go up to the formulas. You have money saved for retirement. Your account earns 9%. How much will you be able to pull out each month? All right, pull out each month is the key. That's a withdraw, and it's every month. And then they even use the word withdraw. So if we go back and think about the situation in our formulas, we have money in the bank, and we're going to withdraw. So the money's going to go down in value. So we have a negative growth rate, essentially. It's dropping each month. So it's shrinking. And then also it's monthly, so we have an end value. So it's this final one. Let's see if we can move that back. Let's see what we have. Okay. So we have 300,000 saved for retirement. That's how much is in the account. Interest rate 0.09. How much will we be able to pull out? Find D. If you want to make each month, so N is 12, and time is 25 years. And then we could find D. Perfect. Last question on this page. How much would you need to deposit in an account now in order to have $2,000 in the account in 10 years? All right, so it says deposit now. So this is different from the previous problem where it's like pull out each month, or question number 1, deposit each month. This is just deposit now. So this is a one-time deposit. So the one-time deposit problem needs this formula. This is just one time, not over and over and over. Instead of D being the deposit each month, it's just a P, the initial principal. So we have A, P, R, N, and T. Let's take a look at what variables, the values they are. So how much would we need to deposit? That's find P. In an account now, A equals 2,000 in the account in 10 years, so T equals 10, R equals 0.07, and compounded monthly, N equals 12. All right. Next questions. During the year 2006, Middletown issued 230 speeding tickets. Okay, each year thereafter, so it's in each year, the number of speeding tickets predicted to grow by 10%. So this isn't a money problem, so it's one of the growth problems, one of the first 3. And because it's a percentage, we're going with the exponential growth. So what do we have during the year 2006? Okay, so we have the initial value, P sub 0, is 230. Every year after, the growth is 10%. And we don't have any more information. We don't have how many years in the future they want to predict or any value in the future. So that's all the information we have for this formula. We would need more information to use it. Next question. You want to buy $224,000 home. Okay. You plan to pay 20% as a down payment and take out a 30-year loan for the rest. What is your monthly payment? Okay, so this is a monthly payment situation. Monthly payment, and it's a loan. So we would go to the loan formula where it's a monthly payment. Okay, let's see what we get. First off, it says monthly payment, so n equals 12. The question is find the monthly payment, so let's find D. We have a 30-year loan, so T is 30 years. I do not know the rate, and I also do not know A directly, but I do know that A would be 80% of the $224,000 because we paid 20% down, so we don't have to borrow that from the bank. So just the 80% left over of the $224,000, that's what would be in the account when we first borrowed this money from the bank. That's A. So we would still need R to answer this question. All right, next one. Suppose a fish population is currently 7,800, and 11 years later the population is 14,000. Use the explicit exponential model. All right, so this makes it easy. They told us exactly which one to work with. The explicit exponential model. Define the growth rate. Okay, so we have the current population. That would be P sub 0. 7,800. We have 11 years, so we have n equals 11. The population in the future, that would be P sub n. It's technically P sub 11, but for the formula, we'd plug it into the P sub n. And that's it. We have P sub n, P sub 0, and we could solve for R. This one would take a root to solve, but that's not this video. Okay, next one up. A rental car company charges $45 plus 25 cents per each mile driven. So every mile you drive, it's always 25 more cents. So this is not a percentage, this is a constant change. We're talking about linear growth. It's always 25 cents more. So the initial value, P sub 0, would be 45. In dollars, since we're in dollars, the D value would be 0.25. And that's all the information we have. We would not be able to use this formula without something else given, either an n value or a P sub n value. Okay, next one. You deposit. Ooh, that's a good keyword. Oh, and then each year. There we go. That's all I need to know for the formula. Deposit each year. That's the one that grows over time with the deposit. Here we have our formula. 2,000 each year. So the deposit is 2,000. N equals 1 because it's each year, once a year. 6% interest rate. Compounded annually. The compounding, by the way, how often it compounds has to match up with how often the deposit withdrawal is made, or else these formulas don't work. How much will you have in the account in 15 years? So T is 15, and then find A. This is a complete question. We have of the variables all but one, and we could find that one. Great. Number 15, assume there is a certain population of fish in a pond. It is estimated, okay, here's the key word, carrying capacity. That's the only carrying capacity. I like to say carrying with a K. That's the one with the K in the formula. Probably won't use this formula very often. It's one of the fewer used applications in the course, but I've seen it on tests. I don't know if I've seen it definitely in the homework. So let's see what we have about this. The carrying capacity, so that's K, is 1,000. Absent constraints, the population would grow by 220%. So that's R would be 2.2%. And the initial population is 200. So P sub 0 equals 200. And that's actually enough information to find P sub 1 and P sub 2, etc. Because if we track with the variables in here, we have a previous value used 3 times, and we have a previous value, 200. That would go in those spots. And then we have R and K, which we have as well. So we could plug everything in to this right side, and we would get P sub 1. And then we'd plug the P sub 1 in these spots, and we get P sub 2. And then we plug P sub 2 into these spots to get P sub 3, etc. So this is actually a complete question ready to be solved. Number 16, last question. Suppose you have 7,400 deposited. All right, so we have it deposited. But how often is it deposited? It doesn't say. Now, it says compounded quarterly, but it doesn't say deposited quarterly. So I'm looking for the keyword like monthly payment or withdraw or deposited annually, but I don't see any of those words changing this word deposited. So that's the difference between deposited monthly, we'd work with this formula, and just a one-time deposit, we work with this simpler compounding formula. This is the one we get for this last problem. It just says deposited. It doesn't say how frequently. So we assume it's once. Okay, so we would have 7,400, so that would be P. We're given the interest rate. We divide by 100 to get that value, 0.20285. There we go. Compounded quarterly, so N equals 4. How long will it take? So it's find T. And then they give us the final value, so that's A, it's 9,300. I think one of the hardest things about these two modules is knowing which formula to use, and then recognizing what in the story problem matches up with what pieces in the formula. So hopefully this video has given you some practice on keywords to look for and concepts to think about, and whether you have enough information given in the problem to answer the question. Okay, I hope this helps.